Hello, students. So, we've studied sets and lists as mutable data types so far, and we've mentioned the dictionary. So it's finally time. Let's introduce it. Maybe with the following example. Let's say we have a list. And what we could do is we could make a list of squares, starting with 0, non-negative squares. So we have 0, 1, 4, 9, 16, 25, 36. Okay. And if I wanted to give this a name, I could even give this a name. And notice that if I ask for the 0th square, I get 0. If I ask for the first square, I get 1. If I ask for the second square, I get 4. So basically, I'm putting in a number here, and I'm getting the square of that number, right? If I wanted s of 3, that should be the square of 3, which is 9. So this works out very nicely. Pretty example. Nothing wrong with it. But suppose I wanted to instead do roots. So what could I do here? Well, let's try it. The square root of 0 is 0, and the square root of 1 is 1. It's working just fine, right? I got no problems with this until I get to 2. You see, 2 doesn't have a square root in the integers. So if I want to make a list of roots, I have to think about what I'm going to do. I could use an approximation, but I don't like using an approximation. It's going to lead to errors, you know, as things accumulate. Maybe we could just, I don't know, do the perfect squares. But the problem is what do I do with 2 and 3 on my way to 4? Like, I got to put something there, and then at 4 I'll get 2, and then at 5, and then at 6, and then at 7, and then at 8, and then at 9 I get 3. So, I mean, what I could do is I could do something like that. I could just say, hey, I'll have it return false if it's not a perfect square. And, I mean, it kind of works. It's not the prettiest thing, but let's try it. Let's try R of 4, and I get 2. And then let's try R of 9, and I get 3. And as you would know, R of 8 is going to give me false. But there are lots of situations I could think of where you want to ignore certain values. Maybe we want something that, you know, just works for primes. Lists always have to start with 0 as the index, and then the next term is always 1, and the next term is always 2. What if we had a way of just storing information where we didn't label them 0, 1, 2, and 3. Oh, one more time. You could think about these as sort of keys as unlocking different values. I want something like a list, but I don't want the keys to be 0, 1, 2, 3, 4, 5, 6. I want them to be whatever I want. Well, there's such a thing called a dictionary. So let's call this root dic, and let's say, okay, I could store the root of 0. I can store the root of 1. What I'm doing here now is I'm writing the index on the left and what I want it to store on the right. So over here, the index of 4 should give me 2. The index of 9 should give me 3. The index of 16 should give me 4. So now let's try this. Let's ask, what is the root of 4? And it gives me 2. Now let's ask, what is the root of 16? And it gives me 4. And if I ask for the root of anything that I didn't give it yet, like, I don't know, the root of 8, something that's not pretty, it's going to give me a very simple to read error message. It tells me, hey, think about these numbers as the keys, right? They're unlocking their given values. So 0 unlocks 0, 1 unlocks 1, 4 unlocks 2, 9 unlocks 3. This is just saying, hey, it's a key error. There is no key 8. You gave me 8. That's not a key. So I can't tell you what it is. So very, very clear error message from Python. As usual, it tells you exactly what you did wrong. Okay. Um, so what if I wanted to add another key to root dict? Let's say I wanted to go further. So, I mean, what I could do is I could rewrite it, right? I could just copy this. Not the way you should do it. But I could do this. Okay. But what I could also do, let's say I wanted to add another one, is I could just say, hey, when I do the index of 36, I want that to equal 6. And then boom, I could even look at my dictionary and it has changed. And I could keep doing this to add any key value pairs. I just tell it, hey, when you get to 49, I want the output to be 7. And root dict is root dict is that. So you can see it added for the key 49, it gave me the value of 7. Okay, so we can keep adding keys all we want here. Let's just figure out, is this actually a dictionary? One thing I could always do is I could say, hey, Python, what is this thing? And Python will tell me this is a dictionary. Okay, so we also know that we have dir and help if we wanted a list of all these different things that we can do with dictionaries. But we don't necessarily want to do that now. Now, you might see that there's a problem. I mean, let's actually just run that quickly. You can see a lot of things. A lot of these things should be familiar to you already. Some of them, like the contains and stuff like that. But you might think of a problem already. This uses curly brackets. What else uses curly brackets? Sets uses curly brackets, right? If you have a set, it uses curly brackets. A dictionary uses curly brackets. Won't this run into problems? The answer is no, not for the most part. You see, when we have our dictionary, what we do is we use the colon to indicate that, these are the keys and the values on the right. With a set, we never have that. A set is something that would look like this. 1, 3, 4. That's a set. So if I have something like this, 1, 2, 3, 4, that's going to be a dictionary. Now, when would we run into trouble? We would run into trouble if they were both, or one of them was maybe empty, right? If I want a set with no objects, or a dictionary with no keys, I would probably use that. So we had to make a decision. We, as if, I was one of the people writing Python. I wasn't, but, the Python community had to make a decision. And they had to decide what this means. So, hey, let's just ask Python. Let's see what they went with. And it's a dictionary. So if you use empty curly brackets, you get a dictionary. And this is why we have to use the set function to generate an empty set. So if you just do set, you don't put anything inside, it gives you the empty set. If you do just brackets, it gives you the empty dictionary. And if you do that, it will also give you the empty dictionary, the dictionary with no keys. But of course, if you let D be an empty dictionary, we can always add to it later. As you see, all we like. So that's your first introduction to looking at dictionaries.